Picture this: a modern air defense network, radar screens glowing with tracks, officers confident they can see everything within 300 kilometers. Then the picture starts lying. Not fuzzy, not weak signal, lying. Contacts appear where nothing exists. Real aircraft vanish mid-flight. Range gates start chasing ghosts. And the people responsible for protecting national airspace realize, too late, that the most dangerous weapon in the sky isn't a missile. It's confusion. So how does a high-end air defense system go blind without being physically destroyed? And why does it happen right when you need it most? First, let's define what blind actually means. We're not talking about radar physically destroyed. We're talking about loss of reliable track picture, degraded kill chain integrity, broken command and control, sensor deception at scale. Here's the uncomfortable truth. If your radar picture can't be trusted, every decision downstream is a coin flip. Do you fire at that track? Is it real? Is it 3 aircraft pretending to be 1, or 1 pretending to be 3? And in air defense, coin flips get expensive fast. You waste interceptors on ghosts, or you hold fire while real threats slip through. The system doesn't need to be destroyed. It just needs to be doubted. Turns out the human part of the kill chain has opinions about firing million-dollar missiles at question marks. Let's walk through how air defense is supposed to work. 6 steps, simple in theory. Step 1, detect. Sensors, radar, electro-optical, electronic support measures pick up something in the sky. You get a bearing, a range, maybe an altitude. Step 2, track. Multiple sensors feed data into a fusion system. Now you have continuous position updates. The blob becomes a track. Step 3, identify. IFF interrogation, behavior analysis, radar signature matching. You're trying to answer, is this hostile? Step 4, decide. Command and control evaluates the picture. Rules of engagement. Threat, assessment, authorization to engage. Step 5, engage. A surface-to-air missile is launched. Guidance, whether radar, infrared, or command, keeps it on course. Step 6, assess. Did it work? Target destroyed? Miss? Need another shot? That's the textbook. Now let's talk about what happens when someone decides the textbook is optional reading. Here's the uncomfortable part. You can have world-class missiles and still lose, because missiles don't matter if the system is aiming at ghosts. Let's start with the simplest method, noise jamming. Your radar sends out pulses. Objects reflect them back. The radar measures time delay, that's range, and Doppler shift, that's velocity. Noise jamming floods the radar's receiver with electromagnetic energy across the same frequencies. It's like shouting in a library. The radar can't hear its own echoes anymore. Practical outcome? Detection ranges collapse. Track quality degrades. Intermittent locks that drop every few seconds. The radar didn't fail. It's just buried under noise. And here's the kicker. Modern noise jamming is directional. The jammer doesn't need to light up the entire sky. It just needs to blind the radars pointed at it. If the radar picture lies, the rest is just expensive optimism. But noise is crude. You know you're being jammed. What's more dangerous is when the radar keeps working, it just shows you lies. This is deception jamming. Instead of drowning the signal, you manipulate it. False targets. The jammer generates fake radar returns. 1 aircraft becomes 5. The operator sees a raid package that doesn't exist. Range gate pull-off. The jammer captures the radar's tracking signal, then gradually delays the return. The radar thinks the target is getting farther away when it's actually getting closer. Velocity gate pull-off. Same trick, but with Doppler. The radar thinks the target is slowing down. It's not. Outcome? The system tracks convincing fakes while real aircraft slip through gaps in coverage. And here's the cruel part. Good deception jamming is indistinguishable from a real target until it's too late. Nothing says national security like a parade-ready system that panics the moment the environment stops cooperating. Now add this: the threat of being targeted. Modern aircraft carry passive sensors, electronic support measures, ESM. They listen for radar emissions. Once they know where you are, they can target you with anti-radiation missiles, feed your position to strike packages, map your entire integrated air defense network. So what do if you're the radar operator? You turn off. You go into emission control, MCON. And that's a form of self-blinding. You're not being jammed. You're not deceived. You're just choosing not to see, because seeing might get you killed. Reports suggest this is exactly what happened in early phases of certain conflicts. Radars went dark not because they were destroyed, but because operators feared becoming targets. It's not a glitch if it happens exactly when the pressure starts. The radar didn't fail. The system did exactly what it was built to do under assumptions that stopped being true around the year 1998. Let's say your radars survive. They're seeing tracks. Great. Now those tracks need to reach the command post. That requires data links that work under jamming, fusion algorithms that reconcile conflicting data, operators who trust the system. Break any of those, and the kill chain collapses. Example: one radar sees a contact at bearing 270, altitude 5,000 meters. Another radar, 30 kilometers away, sees nothing. Which one is right? If your fusion system is poor, you get duplicate tracks. One target appears as 3. Track drops. The system can't maintain continuity. Conflicting identification. One node says hostile, another says unknown. And if the humans don't trust the automation, they override it, or freeze, or revert to manual procedures that weren't designed for high-tempo operations under electronic warfare pressure. Modern systems are amazing until the operator treats the screen like it's the truth instead of a suggestion. Here's the part nobody wants to talk about: training. Deception jamming works because operators aren't trained to recognize it. They see tracks, they assume tracks are real. MCON discipline fails because peacetime habits leave the radar on, maximize coverage, get you killed in wartime. Command and control breaks down because the staff hasn't rehearsed high-pressure decision-making under ambiguity. You can buy the best hardware on the planet, but if your people have never seen a range gate pull-off in training, they will fall for it in combat. Some militaries buy capability. Others buy the appearance of capability. Guess which one is cheaper in the short term? Let's walk through what it looks like when an air defense network goes blind. Not in theory, in real time. Minute 1. First odd track appears. Altitude doesn't match speed profile. Operator flags it as possible. Malfunction. Keeps monitoring. Minute 3. Second track. Then a third. Now there are 12 contacts inbound. Intel said 4 aircraft maximum. Is this a raid? A glitch? Jamming? Minute 5. Operators toggle radar modes. Switch to backup frequencies. Try to correlate with electro-optical sensors. Nothing matches. Minute 7. IFF interrogation returns unknown for all tracks. Command post demands clarification. Are these hostile? Minute 9. Command and control starts issuing contradictory instructions. Hold fire. Confirm hostile. Engage if within range. Wait for higher authority. Minute 12. Half the radars shut down to avoid being targeted. The ones still active show conflicting pictures. The network is now partly blind from emission control, partly deceived by false tracks, partly paralyzed by command and control breakdown. Minute 15. The decision: fire at low-confidence tracks and waste interceptors, or hold fire and let potential threats through. Either way, the air defense network has been defeated, not by kinetic destruction, but by doubt. You can't intercept what you can't trust. Air defenses don't get defeated in one dramatic explosion. They get defeated in a meeting 5 minutes earlier when someone decided training hours were optional. So, how do you prevent your air defense network from going blind? 1. Train against deception constantly. Operators need reps recognizing false targets, range gate pull-off, velocity deception. If they've never seen it, they'll fall for it. 2. Emission control discipline. Peacetime habits get you killed. Practice radar MCON. Use passive sensors. Don't radiate unless you're ready to be targeted. 3. Redundant multispectral sensors. One radar band? You're vulnerable. Add passive sensors, electro-optical, different frequency radars. Make the adversary work harder. 4. Hardened networks and fusion. Your data links need to survive. Jamming. Your fusion algorithms need to handle conflicting data gracefully. And your operators need to trust the system because they've tested it under stress. 5. Realistic exercises that include electronic warfare, not parade ground drills, high-tempo scenarios with deception jamming, CD threats, degraded communications. If your first time seeing this is in combat, you've already lost. Here's the summary. Blindness is usually a kill chain collapse driven by electronic warfare, command and control fragility, and human factors. The radar might work fine, the missiles might be world-class. But if the system, people, procedures, networks breaks under pressure, none of that matters. This is the part where the checklist meets reality, and reality wins. I'll end with a blunt question. Would you rather have the best missiles on paper or a system that keeps working when the picture starts lying? Comment below. What breaks first in a real air defense network? Hardware, software, or humans? And if you ran that operations room, what's the first change you'd make? Hit subscribe if you want more breakdowns that explain why systems fail, not just that they do. Thanks for watching. See you next time.